Good evening, El Paso. Welcome to Philosophic Dialogues from La Frontera, where our mission is to share the fun of the big questions with you. My name is Dr. Kim Diaz, and I teach philosophy at El Paso Community College.
And my name is Jules Simon. I'm a philosopher at the University of Texas, El Paso, where I teach, do research, and write.
And today we feel very grateful to be here interviewing our colleague, Dr. Miguel Vasquez, who teaches biology at the Mission del Paso campus. Dr. Vasquez began his undergraduate biology career at UTEP, where he earned his Bachelors of Science in Microbiology in 2008. During his undergraduate career, he had the opportunity to perform behavioral pharmacologic research at the University of Texas Health Science Center at San Antonio. And this sparked something in Miguel that drew him more towards research in the field of biology. With the research experience he gained during the summer research program in San Antonio, he was able to obtain a Howard Hughes Medical Institute undergraduate research position at UTEP's new bioscience facility during his senior year. This is where he began his research with Dr. Rosa Maldonado, who later became his graduate school advisor. Dr. Vasquez made progress with his undergraduate project and was asked by the principal investigator to consider joining her lab as a doctoral student. Dr. Vasquez applied and was readily accepted to UTEP's Biological Science doctoral program and was given the honor to become a recipient of the Rice Graduate School Fellowship. During this program, Miguel performed research in the field of drug discovery that entailed working with the diseases known as Leishmaniasis and Chagas Disease. These studies required utilization of all the techniques and equipment found in a typical university biology lab, including X-ray crystallography, mass spectrometry, thin layer chromatography, protein purifications, and Western blots, RNA purification, and cDNA synthesis, cell culturing, animal studies in rodents, fluorescent microscopy, molecular cloning, and many other common research techniques. By the time Dr. Vasquez earned his doctoral degree in 2013, he had enough material to eventually publish his own first author publication and appeared as a co-author on 2 additional publications. He ended up getting a patent for one of the inhibitors that he identified for its efficacy against Leishmaniasis and Chagas disease. Immediately following Miguel's graduation, he was given the opportunity to become an instructor at EPCC, and he has been faculty at this institution for over 8 years now, and currently serves as a faculty coordinator for the Mission del Paso campus. During his time at EPCC, Dr. Vasquez has achieved tenure status and has completed many faculty development programs, such as the Teachership Academy and SAGE 2YC. Dr. Vasquez also continued his passion for research and became the first professor at Mission del Paso to give students the opportunity to perform real-world research. This research is through an NIH-funded grant known as CURE, Course Undergraduate Research Experiences, research labs that work in collaboration with local university faculty. During the pandemic, Dr. Vasquez was also able to develop the first ever fully online CURE research lab for online undergraduate students. Miguel, thank you so much for joining us today.
Thank you very much, Kim and Jules, for the wonderful introduction, and I appreciate you guys having me here.
What a nice resume you have already. Young professional academic. One of the things that we've been focusing on is the relationship of philosophy to other disciplines. Right. And so this segment today, this episode today, is about science and philosophy. So what do you think science is all about? You know, what's a good thing about science? What is this phenomenon called science?
Well, science is a great thing, and especially in a society today where we're always looking for answers and being steered all over the place by multiple claims. Science is great because it has that self-correcting mechanism embedded within it. Like I said, in social media, you're being exposed to all kinds of claims and things that you don't know who to believe. That's where you have science to fall back on. because science goes through a process by eliminating things that are false. So the process of eliminating things false, by doing so, you are always inching closer to undeniable truths. And once you are able to find what you do believe to be true based off of any type of science experiment, that's where the best part comes in, is your publications are peer reviewed. So another wonderful thing about science is you can't just make any claim and run with it and have other people misled in the wrong directions, like we're seeing happening again all over society. In this case, the peer review committee was a team of experts in the same field that you're in. So they're going to have a high level of proficiency reading what you wrote about, and they're going to make sure that you were sound in all of your experiments, in all of your claims, that you have evidence to back all of your claims. And if you're in any way trying to portray something that does seem false, you will be rejected and told to redo it until you get that sound experiment that in which they all agree upon can move forward and be published for the entire scientific community to share. So that's the beauty. Once it's shared to through the publication, the entire scientific community now has access to use it for their research to help enhance their research. Another wonderful thing about science is we're constantly sharing our information rather than kind of hiding it and trying to save it for yourself.
I have a follow-up question. So, because, it's real interesting, so philosophic dialogues from La Frontera, and I wanted to say we're here at the boundary of philosophy and science. Philosophers and scientists want to find out the truth. We just go about it differently. And philosophers distinguish a number of ways in which things can be true. One of them is called the coherence theory of truth. And so what it means briefly is that there's already an established body of knowledge as true, and then when a new claim is made, if that claim coheres with the established body of knowledge, then it gets adopted as part of that body. Yeah. And so,
Right.
But the problem with that, one of the criticisms of that theory is that the community that accepts it could be wrong, could still be wrong. And then, so you are consistent, but wrong. And so one example of that would be, let me think. Yeah, we used to think that the Earth was at the center of the solar system, right? At the center of and so it got the peer, so, when somebody, I don't know, Ptolemy sends his paper and says, for peer review. And so the peers have adopted something that is coherent. It's coherent with them, but we're all wrong. How do scientists overcome that hurdle?
Well, usually the scientific method, the process of going through science, rules out and eliminates things that are found to be false. So ideally, if through the process and through many trials, you are always getting rid of those false ideas. But ultimately, there's always going to be some level of falsehood in the claims that we still don't know the truth, where we're still trying to discover the truth. And that's where it is actually necessary in science to have these false ideas, because you can test them. And so not all ideas are testable. That's where science is limited. But once you have an idea and you could test it, that's where you're getting closer to finding out, is this idea even close to being true, or is it completely false? And that's what the scientific method will help us to do when it comes to every individual claim. You could go through the process, experimentation, and come to a conclusion for every single claim that you might have, as long as it's testable.
So then we go back to the scientific method to try
Correct.
to...
The scientific method is the basis of science, yes.
But it's also based on, the way you describe this, it's based on certain kinds of fundamental structures of the universe, right? Like cause and effect.
Right.
Right? So things are happening in such a way in our, ecosphere, in the biosphere, and we see them happening. So, and you know, scientists, I think scientists and philosophers in this way, rather than being different, are pretty similar, because we're a curious bunch.
Very,
you know,
very.
We want to know how things work, and why does this plant flower the way it does, you know, or you know, why do these trees grow up in the successive way that they do, you know, to create different kinds of cover, right? Different kind of ecosphere, right? Over time.
Correct.
So I think in some ways, you know, to go back to this issue of coherence theories of truth and aspiring towards truth, one of the things I heard you say when you said, you know, what's good about science is that it addresses our human, not only, I introduced this issue of curiosity, right, and wonder, but not only that, but also our concern for having a reliable source that I can count on to make decisions, right?
Definitely, yes.
You know, and again, philosophy, and we can talk about this later, but philosophy and science go about this a little bit differently. But I think that that's one of the things that you really focused on, is that you can count on this process of the method and the peer review to provide us a source for something we can count on, right?
Definitely. And ultimately, all of the information we get from the news, from our books, any type of data that's coming out is coming from these scientific journals, and that's ultimately becoming the source of all the information that we believe is fact or true when it comes to medicine or food and different things in that nature.
But it's true in temporary way, right? Because it could still be falsifiable.
Certain things can be, but once one thing has been proven beyond a reasonable doubt, it's hard to, at that point, change what we believe to be true. For example, for thousands of years, we had no idea what we were made out of. We didn't know what DNA was, but it's always been there. We've always been made out of cells. We've always had DNA as the source of our information. We just didn't know it. Not until recently we discovered that, and now we know beyond doubt that life is made out of cells, and we continue examining life forms on a daily basis, and it still holds true. But yeah, it's still known as the cell theory. Mm-hmm. And so we leave room for the possibility that some other world or some other life form might be made out of something else. So the cell theory is stating that we're all made out of cells, and as far as we know it, that's a fact for us, for our lives. But like you said, there's always that little bit of room for the unexplainable to enter the realm of science. And so that's why we do have theories compared to hypotheses and scientific laws, and things are either firmly embedded or still we don't have a firm grasp of the
I
truth
think it'd
yet.
be good for us to talk about the scientific method. How, you know, when your students come into your class and you're going over the scientific method, how do you explain it for our audience?
So
just so that
for
we're
the
all on the same
scientific
page,
method,
right?
yes, of course. The scientific method is a series of 5 steps, which always starts with an observation. So that would be step 1, which comes with a question. So observation and question will be step 1. You see something, you can't question something without seeing it, therefore the observation comes first. You observe the night sky, and just through your observations of being here on this earth, you could easily come to a hypothesis, which would be the next step. For example, they used to believe that, like you said, the earth was the center of the universe based off your observation of the stars. That would be a pretty logical hypothesis at that point in time. So that would be your second step, come up with something testable, your best guess. So based off of your experiences, your knowledge, you're going to come up with your best guess or your hypothesis to explain that initial step, the question. So you have your question, you have your hypothesis, and then you're now going to test your hypothesis. That's step 3, experimentation. And your experiment is going to completely address your hypothesis, only your hypothesis. And what you want in any sound experiment is just one variable. Only one thing changes, everything else is controlled, so that when you come to your 4th step, the results, you would account that result to that one variable and nothing else. And that's how you're able to rule something out as whether being the cause or not the cause, because there's only one variable in your experiment, only one thing that changes between the two groups, the treated group and the untreated group, for example. And therefore, you have now your result, which is going to then give you a conclusion based on your original hypothesis. So again, you observe something, which gives you a question. You come up with your best prediction or hypothesis. You test your hypothesis. You come up with a result. The result's either going to give you a yes or a no or some type of numbers. Usually, at this point, you do a statistical analysis. We've even ruled out human error at this point, where we fully use statistics to say this is significant or not significant. There's an actual number line that will, draw out whether it's statistically significant or not. And based off of that statistical analysis, we could safely come to a conclusion that yes, my hypothesis was accepted or my hypothesis was rejected. And at that point, in the conclusion, that's where you can easily falsify something. Say, if you prove false at that moment, then you can now move on to a new idea or a new hypothesis. That's where it never stops, is when you find out that your hypothesis is rejected, then you have to come up with a new hypothesis and just keep going until you eventually find the answer to what your original question was. And through that process, even though it might take many years, decades, eventually we've been finding lots of answers as through the field of biology. We know now what we're made out of, we know what DNA is, how it works, and it's all been through this process of the scientific method. Computers, we once had the question, how do you make lights do what we want? And now we have computers on our phones, and we're making them better every day, asking the same, using the same process. How do we make this device better? Maybe we add this, try it out. Most of the time, you reject the new ideas. But
do you think it's possible that we'll ever get to teleport ourselves?
That would be amazing, but no, I don't think so.
I was going to ask about the relationship of science to science fiction before our, at the beginning, before we even started filming, but that's a really good question.
Would avoid traffic? It would avoid traffic.
See, that's the bummer about science and knowing too much, is you realize certain things are not possible, like Jurassic Park, for example. I was pretty bummed out when I did some research into dinosaur DNA and found out that it's pretty much impossible to find a DNA that's still intact.
Recreate the eggs.
After 65 million years. However, they are doing it with mammoths. So mammoths, they're not old enough to where their DNA is completely destroyed, so they have found some ancient frozen mammoths with intact DNA, and they're currently trying to clone the mammoth. So
this is interesting. So there's so many issues that got cropped up in my mind,
right.
Popped up in my mind just by your explanation of the scientific method. One is the issue of the relationship of science to technology. Because with technology we extend our reach. Mm-hmm. I can see the subatomic world, for instance, where I can measure it. I can not necessarily see it, and that comes to this other point where deeper into our interview, we're going to get to the question of creativity in science. But as you were talking, I began thinking, about variables. So how does a scientist come up with this or that variable to add into their experiment that's going to lead to whatever?
Well,
because I've got this effect that I want. I don't want any virus, right?
Right.
Well,
so how do you come up with that missing variable?
Well, I want to say something here, and I'm going to go off on a tangent.
I thought my tangent was pretty.
Well, no, it's a really
substantial.
good tangent, but the thing is that, tools allow us to measure things that we wouldn't otherwise, but humans are not omniscient. We don't know everything. So, to be omniscient means to know everything, right? So, to identify all the variables, all the possible variables, that is not possible.
Not in one experiment, but through a series of
An
many
infinite.
experiments, every experiment can have a different variable. So one variable could be time. You use different amount of time between A and B. Another experiment could be temperature, and then changing conditions. There's a million different ways you could change a variable. And to go back to your question, it's going to depend on your hypothesis. Right. Was your hypothesis predicting that it was the temperature that was causing the change? Then that's going to be your one variable. If your hypothesis is going to dictate whatever the variable is, and that's why the experiment is going to be fully dependent on your hypothesis.
And fully dependent on my trust that everything's going to happen because of this cause-effect relationship, right?
Right. Well, that's where your background knowledge, your experience comes in. So so your hypothesis is going to be kind of based on how much experience you had. But in the end, you're trying to rule out that I want this to work.
Well,
you're trying to rule out that fan-like mentality that you want it to be this way because that's kind of how you envisioned it happening. But it doesn't always happen that way, and sometimes that frustrates the scientists. They believed with all their heart that this is the cause for this disease, or this is why this was happening, and then they come to find out through their experiments that it's not happening.
Failures.
And they try to prove it in a different way, but they can't get there. So you leave out that bias, and you just go like whatever happens. That's
that could be an ambition bias or whatever.
Confirmation bias.
Could be that too, but also that I just want to get this before who was it? Who was Darwin's counterpart who was doing the same thing?
Leibniz and Newton.
Darwin with
calculus.
No, Darwin who was.
Yes, I know. I'm just having a blank right now.
I am too, but anyway, there was that competition. That was spurring Darwin on to do publish.
Proving our point. We've forgotten his name because he
didn't
get his publication
That's
out
right,
first.
because he didn't get his publication in, right? But that doesn't invalidate Darwin's work, right? Just because he had this other ambition.
Right.
But what another thing that struck
Alfred
me.
Wallace.
What?
Is it Wallace?
Wallace. It was Wallace.
You're
good. Yeah. You're a little closer than me. But I used to teach Origin of Species every other semester, but I stopped a long time ago.
Well,
but I wanted to get to this other point about, you said rather quickly that, over time, could take a long time. There's a million different possibilities, right? So to be a scientist, you got to have a certain amount of patience, right?
A lot of patience, yes, definitely.
A lot of patience, and there's going to be a lot of failures and a lot of failed
more
experiments.
negative data than they call it when you get a negative result where you find out I was wrong or my hypothesis rejected. They call that negative data. So there's far more negative data in research than positive data. There's you could have 1% of the time positive data, and usually that's enough to come up with a publication anyway. So
yeah, given that, coming up with a publication almost seems like a consolation prize where you're showing that nothing worked.
Almost
right?
is, right?
But given that there's so much failure, right? You have got to be also pretty dedicated, not only patient but dedicated.
Definitely dedicated
motivated to learning to begin with, right? Because you have to know the history of science
and
in order to get to the point where you can have any experiment that's going to make sense, right?
Right.
And also have a sense of commitment to a community. Everybody, check it out. I failed in all those ways. So you can learn, so you don't don't recreate my failures because I've already figured out this stuff don't work.
Exactly.
Pat in the back. I failed many times, right? Well.
Yeah, but there's also a record, that in terms of history, there is a record of we humans successfully figuring some stuff out, right?
Right.
Like we did figure out the difference between heliocentric and geocentric theories of the universe, and that it made our understanding of the world we live in better and more navigable, right? Once I figured that part out. Similarly, once I figure out how viruses and different infections and diseases work, then I can either figure out how to block them or something like that,
Mm-hmm.
or how to kill them off.
I have a question here, though, related to everything we've been talking about. And that is, okay, so you get closer to the truth by failing and eliminating these ways in which your hypotheses didn't pan out.
Mm-hmm.
But it seems to me that a scientist also has to have some level of creativity, right? Because it seems like what a scientist is doing in some way is a lot of problem solving.
Yes.
And so it requires, problem solving is sometimes it calls for a person to think outside the box and to be creative. And
Right.
yeah, so do you think that scientists are discovering? You've mentioned we discover that, we humans are made out of largely protein, right, or other chemicals, but is it discovering, or to what degree are scientists creative?
So scientists, the best scientists need to be very creative, because like we talked about, when you run into a dead end and your hypotheses aren't working, that's where creativity really helps you out. You're able to think of things outside the box that normally you wouldn't think of. So the creativity is really needed when it comes to your hypotheses and your experimentation. You need to be able to come up with different ways to tackle your hypothesis. In any given publication, you can't just show something one way, you have to show it multiple ways, or your paper will get rejected. So you have to show that your idea did prove true through this experiment A, experiment B, experiment C, and ultimately that's going to, lead us to a more sound paper. And
So are scientists creating or discovering?
So we're discovering hidden truths or scientists are discovering hidden truths that have always existed. We're not inventing or making up truths, and when we do that, we don't call it a truth, we call it a hypothesis or a theory, which we know is a prediction that may be proven wrong one day. Even theories, which a theory is much different than a hypothesis, because a theory in science is something that has been proven over and over and over, many hypotheses proven. So for example, the cell theory was proven by the microscope. We were able to see all kinds of life forms, and we see cells. It gave us a pattern that gave us then the cell theory. Same with the theory of evolution. Life evolved from other life forms. They kind of made the jump in the theory of evolution that we all evolved from bacteria, for example, even though that was kind of a big jump. But we still leave it as a theory, not as a fact, for that reason, because there may be something false in these theories. We may be proven wrong tomorrow. We don't know. So, but unfortunately, a lot of theories, we behave as if they're fact. So that's one flaw I do see in science or in scientists, is they'll run with these theories all the way to the end as if they're fact, and if they run into a dead end, then it may be because they're trusting a theory as if it's fact, when really maybe that theory might be false.
I think it's fascinating to kind of reflect on myself as some highly evolved form of bacteria.
Yes.
It's just like, well, what form of bacteria am I?
Right.
Yeah,
Philosophers, we all want to know the truth, but I think humility is important, and just acknowledging that we're not omniscient, and that we are proceeding as though this is fact and established because it has been verified so many times. However, we could still be wrong. So I appreciate that in people that, in experts in their field, right, that we acknowledge, but I could be wrong.
Right.
So.
Important. Yes, as scientists, we understand that humans are fallible, and we should understand that, and to the point where all efforts are made to rule out human error in all papers, all experiments. That's again why we have our statistical significance and our scientific method, and so we're just constantly trying to rule out any level of human opinion and any way that we could mess it up, even the math part. You know, we have computers doing that for us nowadays, because you never know, we could mess up an equation, just like the story of I forgot what year it was when the NASA space shuttle exploded.
Mm-hmm.
It was just because one of the
86, I think it
mathematicians
was.
forgot
Yeah.
a negative. But with the computers nowadays, that wouldn't have happened. So now we're trying to, like I said, eliminate our human error as much as possible.
Yeah, and with supercomputing, we can get pretty close to eliminating a lot of that
Exactly.
kind of error.
We've gotten pretty close to eliminating, but there's still always.
Yes,
I
because
mean, there's still humans.
Right, the computers are being
building the
designed.
computer. We're building the
exactly,
computer,
the
so
software. Yeah.
There's always going to be a certain level of human error that you can't avoid.
And so, yeah, I mean, so there is no escaping. It's like with Immanuel Kant, right? It's what we were talking before the show. There is no escaping the fact that we humans are always already categorizing the world in time and space. The categories of
Understanding
of
how we understand.
there is no escaping
And
that.
we still don't understand the physics behind the universe and the micro universe. If you learn about the physics in the macro world and the micro world, they both feel pretty sound in their theories and where they've gone. But when they combine them, they don't mix. So there's something off in our understanding of the universe and how the cosmos interact with.
And that's why I
with
feel
the
philosophers are
micro
still
world.
employed, because there's still that we don't know.
Yes.
We don't really know.
Well, I think that there's a different way to approach this.
Well,
you
it's
know.
a joke for me that I joke with my students.
We
Because you
sort of-
can't Google. You can't Google those questions, the answers.
You
so
still have
can't
to hire a philosopher so we can tell you that we don't know
Well,
everything.
just to keep raising questions.
Yeah.
You
Well, there
were
is
gonna-
that there is that issue of pairing, as you said, Miguel, at the very beginning, observation and raising questions both go together. But then at the same time, I think there's a third dimension. So there's the observation, like this is what I do as a perceiving being, right? And I raise questions because, as a perceiving being, I can't always trust what I perceive, right? But then the third dimension is, and this is, I work in an area called phenomenology, and this is a central tool in that subdiscipline in philosophy. What's my intention? What is the intentionality of a scientist, right? It's not just to avoid error, or it's not just to say, oh, I can, have my fellow peers or scientists to back me up. But there's got to be something else going on that really kind of sparks the plug for a scientist. What is that kind of intentional work that goes on in science? For instance, for you, there were all different kinds of intentions you could have had as a scientist, but you ended up following the one that led to your contributions to Chagas disease and, I'm going to get this wrong, Leishmaniasis,
You got it right.
Got it.
right? Maybe you could just say a little bit about how that intentional structure came about.
Well, usually for me it started, you just want to, help save the world. That's one of the things.
That's great.
That's one of the things that you can, as a scientist, you can be part of. It's just,
Yeah.
I want to combat global warming, or I want to help, children that are hungry, or I want to help elephants in Africa. You could go out in the world and help and make a difference. That's one of the beauties of science. So it usually starts off with a passion. You live in an area of endemic area for Chagas disease. That's usually most of the researchers for Chagas disease and Leishmaniasis are coming from areas where they see people suffering from these diseases. So at UTEP, my principal investigator and her husband, they are from South America, and they're in areas where Leishmaniasis and Chagas disease were prevalent. So you kind of see that it's more of a passion where it hits home. I see a lot of researchers coming from El Paso that are looking towards things like sustainability and, how does the border affect different things. And so it's kind of whatever hits home, whatever you're passionate about, whatever you've always thought about growing up, like, I wish I could help this issue. And in science, there's unlimited ways to help these issues. That's kind of how I see the intent, even though that's not always the scientist's intent. Sometimes they just, they want another publication. It's their job requirement. Sometimes it's like if you're not getting out that publication, you're not getting that grant money for the university, you may find it difficult to keep your job. So sometimes it's like everybody else, you're trying to get some money out of it.
Yeah, there's an economic dimension to it as well, besides just these kind of highfalutin, pure sorts of ideas like inspiration and dedication and creativity and patience. There is an economic aspect to doing science, and we can see that pretty readily in how science relates to the business world, scientists and science, right? I mean, there's the save the world scientist, like I want to have, find the next cure for cancer or this Chagas disease or whatever, right? And then there's those scientists who get engaged in, what can I employ this method to that will lead to making money for this business I work for, right? So like ExxonMobil, what's the best science that is going to release that fracking gas or whatever?
There's science. That's the other thing about science is you could apply it to any field. So they use science in business for those same reasons. Like, how do we maximize they start with the question, we're observing that our profits are going down, and what can we do to enhance these profits? They test out a new strategy or marketing and
new drug.
Some new drug. It works, it doesn't work, and you move forward from there. And so
if it doesn't, and if it works, if it works by this small percentage of effectiveness, because you talked about the data, right, verification.
Right. So, and it also depends on the type of field you're in, the experiment you're working on. Some things could have a lot more positive data than other.
I want to ask, because we're already dancing around it, what is the relationship between ethics and science? And so ethics, ethics, we've talked a lot about science, and Jules teaches ethics a lot. So how would
science.
What is ethics? What is ethics? Could you tell us what is ethics?
Oh, ethics is as a philosophical discipline, it's a formal way to study the variables that are entailed by the decision-making processes that we go through. Like, how do I come up with this or that decision to choose this or that action in my life, right? Mm-hmm. So, and we have different ways to understand that, different methods, right? Like the scientific method, there's different theories that philosophers have developed, which hold generally and for the most part, mm-hmm. right? Like a theory of duty or a theory of utility, and those theories work, but not for everything.
And I want to give my own.
But ethics is this kind of relationship between decision making and paths of action.
The way that I would define it is it's the philosophical study of morals. All of us have, mm-hmm. Picked up values from school and parents, society. But when we do ethics, we're questioning whether those values make sense and why. So why is it ethical for me to euthanize someone or not? Is it ethical to conduct research with animals? Right. And so then you have all these theories like duty, utility, virtue.
Well, the why questions are important. I mean, that's a meta-ethical issue, right? And that's why I resist thinking about ethics that way, right? But if you tie it to action, if you tie ethics to action and decision-making, then you can see why ethics in science is really important. Because if I decide to pursue save the world approach to science, it's going to lead into a much different communal phenomenon than if I decide I'm going to maximize my profit-making ability as a scientist, right? Mm-hmm. And to hell with the environment or whatever. Right? I can use my science to make a lot of money. Right?
Well, but as scientists, I'm sure you all have to take courses and certificates because ethics is everywhere, and doing ethical research. So
being in science, we are constantly aware of ethics. Being in research, you're required to take ethics training, especially if you're working with animals. You have a higher level of ethics training. So we're constantly thinking about any harm that we're doing to any animals. Like, we don't want to be a part of, any companies that we find out that are, mistreating the animals. So we're always trying to maintain a high standard of ethics, even though a lot do believe what we're doing is wrong by testing animals. But how we see it is, it has to be tested on someone. So it's either we test it on humans first and they suffer the effects of a drug that didn't work, or we're gonna need to do it in animals. And so is it more ethical to do it one way or another? That's why we need philosophers to help us with these types of things. And so in the end, we're just trying to do our best to, like I said, to maintain an ethical protocol, especially when dealing with animals and living organisms, that we're just trying to keep them comfortable and not stressed out as much as we can, even though it's hard to minimize that in some experiments.
I want to say also, as a scientist or as a philosopher, again, we're not omniscient, so we are working on a theory, but we don't know how that theory is then going to be used by the public.
Right.
And used or abused. And so even though, so you might come up on a finding, but then if someone else who wants to profit of it, and so this is our next question. What is the relationship between science and politics?
Yes, so definitely there's a lot going on with science and politics. Ultimately, science is the pursuit of knowledge. You're trying to establish facts and add it to your informational network, and then this knowledge starts to bring about more control and power. Because you have this knowledge, you have a little bit more control and understanding of things and more power, and ultimately that's what politics is. Politics is being in power and establishing the rules, and science is all about this knowledge, but then the politicians will use this knowledge, as you mentioned, for or against their case, and in a way it's being misused by politicians because they're only giving it credibility if it works for their party, and if it doesn't, if it works against their party, they're gonna make everybody believe it's a big conspiracy. For example, when global warming first came out, it was a big liberal conspiracy. Decades have passed, and we're physically seeing the effects of global warming. We now know that it's almost fact beyond doubt. And
the houses are starting to fall into the ocean.
Right. So now it's obvious that global warming is happening, and it wasn't really, and so for many years and to this day, people still believe it's a big conspiracy, and that's again what I talked about. One of the drawbacks that's going on in society. People are able to say whatever they want. They have all these different outlets, followers, and so they'll gain these big masses of followers that are following something that's completely false because they ignored the science.
Do you see hope? I would think that as a scientist you do, but then I'm thinking, in terms of like the history of philosophy, we're trained in the humanities, right? And I'm thinking it's been the same. The scientists back in the medieval times would get dunked in rivers, in house arrest, or burnt at the stake for blasphemy because the authority at the time did not want to be, obviously wanted to remain in power. And so curious individuals who would conduct experiments or come up with theories that contradicted what the established ordered. Right? And so then would get disappeared or killed. Back then they just flat out killed them, or placed in arrested. So then, or killed. So like philosophers have gotten themselves killed a lot. So it's been like that. It's like same as it ever was. But when the theory is, or when the science backs up what the people in power want to claim, then science and there's been so many, like one example that I keep bringing up is the científicos during the Porfirio Diaz regime. They this was French logical positivism that was adopted by the Mexican government at the turn of the 19th to the 20th century. And so the scientists were lauded, and they were running, they were a big part of the legislative and judicial body. So in Brazil, but it was also all over South America. Like in Brazil, the flag, it says order and progress, because this was the idea of, again, logical positivism, order and progress, right? Yeah, when it's in the interest of those in power, science, same as logic and reason during the medieval ages, a lot of the logic that got done through the medieval times was by monks trying to prove God's existence. So using the tools for what was of interest to whoever those were, who was in power. Anyway, my whole point in this is do you have hope? Because that science will be given its place instead of being used.
Well, I do have hope for the long term, but short term, I don't see any hope right now, especially the way that our system is set up. I mean, we have politicians making decisions that are biology related, and they've never taken a biology class their whole life. So I think we should have more experts weighing in on decisions that involve their field. If it's a big law involving DNA, we should have lots of, biologists who've been working with DNA in on those decisions instead of, I feel like there's a huge lack of scientific knowledge, biology knowledge, philosophy just in the government in general. And they're more business, focused on business and, the judicial system. And so they're more tuned into what they're specialized in. But when it comes to making big decisions that affect the world, they're not as informed, but yet they're still allowed to make those decisions. That's where I think we're going wrong, is the ones in power aren't informed or educated enough to be making the decisions that they're given.
But then it's a catch-22 for scientists, because then I would assume that if scientists get involved in politics, then that questions your objectivity as a scientist.
Right. There's got to be a way to, have like an independent body of scientists, just have them involved in more decisions. And they have to make it independent. But you're right. I mean, you get involved with the politics, you get sucked in, and one party will have you favoring their side, and money, and gets involved, and so there's always going to be those issues. That's why, again, we have human error, because we have nothing but humans and opinions running our government, and a lot of what we do is not based off of science or the scientific method. Yeah, so I think the government should apply some of what we're talking about to how they introduce policies and whatnot, and maybe a little bit more experimentation before they do decide to introduce a policy. I know they do look at data and stuff like that, but the more science they could get involved, the more scientists in these big decisions, I think the better off our world will be.
I like how you're assessing that situation, Miguel. And it seems like, no, in terms of no hope for the short term, which is what you said, right? That seems to me, plausible that it's not going to be a bright future in the short term, right? Because we don't have a good working relationship, a good ethical working relationship between science and politics, between scientists and politicians, right? So we don't have that good relationship because, as Kim said, if a scientist is getting involved in politics, then their objectivity is being questioned and their partiality, their impartiality. And on the other hand, a politician is going to be manipulative. This is how we think about them, right? Manipulative and exploitative to stay in office, so they're just going to use science for political purposes, right?
Yes.
So we are in this catch-22.
We are.
Where, scientists don't trust politicians, politicians don't trust scientists. So when they try to work together, it's always questionable.
Yeah.
And then, like I said, if it doesn't work against them, they're going to do everything they can to put out misinformation to make sure people don't believe this new scientific article that's going to hurt their party. So we're in the misinformation era pretty badly right now. And so I think that's another issue is we have this beautiful thing of science and science publications where you should be going to get all of your information about prescription drugs or this disease or that disease. But instead we're going to social media and reading people's Facebook posts and saying their experiences, and we're going off of them or just anyone that's posting anything. So our sources of information, there's too many now, and a lot of them are not backed by research or not peer reviewed. So I'm always telling my students, you want to know something about anything biology related, and you want to know the truth about what you're taking or what your parents might be taking, and look up the literature, look up the scientific journals. Don't go straight to the first website on Google, because they're just going to want you to know the minimum they want you to know, and you're not going to know the whole story of it. So that's why scientific journals, I say, that's your best source of information for anything, and try to avoid just believing anything you hear on social media or even on just TV.
So then would you say education, as we are teachers, so that for me that it's a commitment and hope that we can help our students feel confident that they can read a scientific, journal that is peer-reviewed which requires more rigor than just looking at social media, right, or just sitting down to look at the news. So I feel like part of what we do is empower them to question whoever claims to be an authority about this or that.
Yes.
And to think for themselves. So maybe that will be the hope, right? That we hope our students will.
Yeah, that's one of the first things we teach in biology is sources of information, since everything that we talk about in biology came from some type of scientific journal. We kind of established that this is where the information is coming from, this is why we get it from there, and this is why this is your best source of information, because hopefully they take that and run with it. But again, we're living in a dangerous times where it's hard to know who to believe.
We are living in dangerous times. There's a war going on. There's people that are struggling to get basic necessities met, like food and shelter and protection from disease. There's so much to talk about. We only have a few minutes left. So I want to raise this one question. Given all the serious sort of intentions that can be directed towards doing science, to save the world or make a lot of money, what do you find that's fun? To get to the fun of the big questions, right? What do you find that's fun about doing science?
Honestly, I just love the ability of understanding how things work, understanding what's going on inside of you when you're feeling wrong, just eliminating that feeling of the unknown. It's just the feeling of the unknown is what most people, are left feeling uneasy whenever they're not sure about something. It gives you that clarity on understanding how things work. Not necessarily everything, but of course, whatever field you're in, you're going to understand more of that. But being a scientist, it gives you that inquisitive type of brain where you're always questioning, like, how does that work? How does that happen? And you're going to go try and figure it out, whether it's on the internet or through experimentation. You're going to go do research, see if somebody else already did experiment on that. So it's kind of like being a scientist, you have that toolkit for being able to tackle problems and solve problems. So I love that aspect of science, and it's just a thrill of being able to discover new things and helps by discovering new things, you're helping to save the world. As you mentioned, one of the compounds I discovered was patented and potentially going to be used for treating, kids and adults across the world. So that would be my little piece of helping save the world. And it was a huge thrill once I was able to discover, hey, this compound that we had no idea about anything about it, we now know it might be a potential therapeutic drug. So
I'm glad you got to that, because at the back of my question was, besides being fun, what role do patents play in the whole scientific endeavor? And you said part of it, it's
Right.
going to be used and patented so it can be relied upon to help cure diseases in other people.
So the patent is mainly just kind of like reserve something that this person was the initial inventor, or this was the first person to discover this compound. So the patent kind of like establishes that you were the one in charge of it, and any future use of this compound kind of goes through you, because you're the one who discovered it.
Well, you get credit for it. You not only get
Right.
credit, you get paid for it, and since it's advances knowledge of a disease or something like that, it's good credit.
Right, it's good.
It's good payment. That's a nice way to look at patents, right? But patents can also be used to kind of put a stranglehold on.
And yeah, that's the
helping
only
people.
time you'll see scientists kind of hiding what they're doing. They're waiting till they publish it. They're waiting to share it. So they're going to share it eventually. But in some cases, like in the discovery of the structure of DNA, they had to steal some data from another lab to get to the final product, which was the structure of DNA. So in the end, you want to collaborate as much as possible, and hopefully, your collaborators are open to sharing everything with you. Sometimes they're not. But the best science is a collaborative effort. You're all working together, whether it's with universities across the world or within your area. You're putting together pieces of the puzzle that maybe your lab didn't have the equipment or technology to do, but they did. So you have a compound you discovered, you could send it to a lab in Germany, and they could test it on an enzyme that they have that you don't have, give you the results, and that's part of your paper. All you have to do is give them credit on the paper. And that's how you also build your repertoire of publications, is helping others, sending them your results, sending them your compounds or whatever you discovered, and then you get put on the paper too.
Well, I want to thank you for collaborating with us in our dialogue.
Thank you.
and
No,
share-
I thank you so much.
Sharing a
This
little
was great.
more knowledge about science with our audience, and hopefully that some of our audience members will check into your class or
Yes.
send their students, send their children rather to be your student. I think it's been a wonderful dialogue today.
Yes, it was great. Thank you very much, Kim and Jules.
Thank you,
It's been
Miguel.
great, and I love being here.
And thank you to our team. Thank you to our audience. This has been Philosophic Dialogues from La Frontera. Please check out our YouTube videos and join us next time.